Hello, Hassan.
Hi.
Hello, Hassan. Are you there?
Yes, yes. Am I audible? Hello? Hello?
Speakers have not yet arrived.
Hello? Am I audible, John?
You are audible. Am I audible, sir?
Yes, you are.
Why aren't you visible? There you are. Office mode. Good afternoon, Revdi.
Good afternoon, sir.
Good afternoon, Jimmy. I see Ritu Kaur. Ritu, good afternoon.
Hi, John. Hi, Hassan.
Hi, Jalaj.
Hi, Jalaj.
Hi, Revti.
Hi. Hi. Hello, ladies and gentlemen. Welcome you all for the webinar today. Thank you for joining with us today. We Numerical Analytics Instruments hosting this webinar. And today's topic is effective use of TI NSPIRE CX2 in probability and distributions. I'm Revati. I'm from Numerical, working as a sales manager, and I have my colleague today. His name is Hassan. And we have two wonderful speakers, Mr. Jalaj. Hi, Jalaj.
Hi.
Hi. And we have Mrs. Shraddha Nayak. Hello, ma'am.
Hello. Hi, everyone.
Hi. Okay, just to give a small introduction about Mr. Jalaj and Mrs. Shraddha. Jalaj is an IB and IGCSE math teacher working in Indonesia. He is a TOK instructor. Jalaj worked in India in many schools in Turkey, Nepal, and now currently he's in Jakarta. He's one of our TI trainers. And Jalaj is an examiner for IBDP Math HL Paper 1 and IEA moderator for HL Math. About Mrs. Shraddha Nayak, she's currently head of math at Oberoi International School, and she's one of our TQ certified trainer. TQ is actually Teachers Teaching with Technology. It's certified by TI, and she's one of the TQ certified trainer. And she has taught in many IB schools in India and international schools in Japan and Malaysia. As an educator, she has over 20 years of work experience, and she holds Masters in Science from Bombay University and Masters in Secondary Education, New Jersey, USA. And I hope Mrs. Shraddha will lead first and then over to Mr. Jalaj. Over to you, ma'am.
Yeah, let me share my screen. Yeah, can we just share my screen? Okay. Can you give me the rights to share the screen? Yeah, all right. Good afternoon, everyone. So I will be, we decided to do a webinar on probability and statistics today. The first part of my webinar is going to be on a, an inquiry-driven strategy that we can use, that I have found useful in teaching my classes, both SL and HL. Then that will be followed by 3 or 4 questions from past papers, which are based on probability distributions, right? If you have questions, I'm sure you will record them on the chat, and Hassan or Jalaj will let me know, or if it is possible for them to clarify any doubts, they will do so, right? So the first thing I would like to mention, one thing before I start, is that I wanted these documents to be shared side by side, and I could not share the ones that I have kind of saved in my emulator. So Hassan kindly showed me how to, just an hour or so ago. I just called him and he said, oh, it is, and together so I'll share that, how I did that, in case you are interested. If you know, that's well and good. So the first thing, so this is what I prepared. I'll just let you know what I'm going to do here. So this is one. And the next part, which, excuse me. Yeah. I have also shared the document with Hassan, and I'm sure he will share the document with you. And the document looks something like this. I've had the questions. I've had these questions posted on the first part, followed by the mark scheme. And the parts in blue are the ones that I find, students can effectively use their NSPIRE to kind of creatively get to the answers. It is time efficient. It really shows their understanding of the calculator as well as mathematics. So there's certain things I'm going to focus on the strategies that we can mentor our students to use on examination questions. Right. So the first part is I found this, I was attending a webinar and I really found this useful. So I'm just going to share this, probably take about 10 minutes to show. So this is when I introduced the normal distribution. I've had students, struggle with the concept. And I thought this could be, if students can inquire themselves, it is one of the best, moments for teachers, for students to discover themselves. So I'm going to kind of open up a lists and a spreadsheet page here, application. This also showcases how different applications can seamlessly be combined and interactively used. So this is one other thing that I really like to use. I've used both NSPIRE and Casio, and these parts that I'm going to showcase really stand out when I'm using my NSPIRE. So I'm going to kind of just list the names here, and I'm going to just write X value and P for probability. All right, this is just to define them. And now, having done that, I'm going, so there are two ways. I could either go to menu and I go to statistics, and I can, excuse me, just a moment. Yeah, I go to menu, I can go to, excuse me. Okay. So first, let me do the other part here. So I'm going to open another page, all right? And I'm going to use data and statistics here. And now that the variables have already been defined, it's very easy for me to just kind of use them as my X and Y variables, and I'm going to do probability. There's nothing that is happening here right now because I still have to define my function. I go to menu, I go to analyze, and I plot the function here, and it is normal distribution. So I'm going to type norm PDF. Okay. It recognizes because there's a change in the font, and then I define it by X using the variable X, comma, And since this is this is an activity, I'm just going to use numbers that students can easily relate to, with mean of 100 and standard deviation of 5, and I'm going to press enter, right? There's still nothing happening because the scales are not compatible. And I'm going to go to my menu, and I'm going to go to my Windows settings, and I'm going to adjust them accordingly. So my X minimum with 3 standard deviations, it would be 85. So I will choose 80. And if you know, to navigate through the fields, you've got to use tab. So I'm going to navigate using tab, and this would be 120. Again, using tab, I go down to this field, so that's 0, and I go down again, and I'm going to enter, oops. And then just make this as 0.1, because this is kind of squashed. Excuse me. And then go to OK. And you have your normal distribution. Now, this really gives them, this is the starting point. And now I'm going to plot values to show them the area or the probability of values lying one standard deviation from the mean. And I could do that going to analyze again. And now this time I'm going to plot a value. And I'm going to define this as 95 as being one standard deviation away from the left. And I can do the same thing with analyze here, plotting another value, and I'm going to list 105. And when I go back here to menu, and I analyze and shade under the function here, right, from this part to this part, you can show them that it is approximately 68%, right? So this is one good activity. I could go through V3 and V4, and these values are listed under variables. So I'm going to show you a different one in just a moment. So I can redefine a value here, or I could plot another function, because now let students investigate or explore what happens with the change in mean or standard deviation. And it's really very easy activity. So you can, now I'm going to kind of analyze and plot another function. And this time I'm going to go for X and do a horizontal translation by changing the mean. And I'm going to say, okay, what happens when you change the mean, but you do not change the standard deviation? And then when you plot here, you see, you can explain to the students how the graph has horizontally moved to the left, and you can make those changes again, because now it is kind of, our domain doesn't kind of take into consideration the new function, and you can make changes. We can also kind of go and plot another function here. And this time I'm going to okay, this time I'm going to plot the function here, and now change the standard deviation, and just have a discussion about what do they think would happen with a change in standard deviation. So I'm going to have 100 and maybe move on to 8, and we can talk about the parameters, what impact these parameters have on the normal distribution, and have a rich kind of discussion going on there. So now the other thing that I just want to quickly bring to your attention is, I can open up another application here, and to get an application, just in case you are finding your way through the use of TI NSPIRE, you can just do Control+ page, if you see here. And this time I'm going to add a calculator here. And now if I go into menu here And I am just, since I've defined my variables V1 and V2, I could have gone ahead and done V3 and V4. But since, we run short of time, I'm just going to show now you can have, since these have been defined, you will always find them here in your stored variables. And again, I navigate using my tab. If you see, I have, you can use your tab, and you can do Shift Tab to kind of move the other way around. And I can, if you click here to the arrow, right arrow here, you find your other variable. Your mean is 100. That was the first one that I defined. This is 5, and I can still get the kind of, you can reproduce the results on the calculator page. The other thing is, I also tend to talk about the document settings, about 6 float, usually 3 float 3 works, but sometimes if you have a value that has 0 preceding by zeros, then having extended float helps. Do I have any questions? Hello? Can you hear me?
Yes, ma'am. I have no questions in the chat box.
Okay.
Yeah, you can proceed.
I was a bit bewildered because I thought nobody could hear me because there wasn't any response from the other side. Okay, that's good. That's good.
No, you're audible. You're audible.
Okay, thank you. All right, so I'm going to move on. There's another activity, especially for standard level. There was a question in the higher paper 2 questions where they'd given a list of values, and they had asked a constant to be added or a constant to be multiplied and find the new mean, the new standard deviation, and what influence it has on. So all these can be little mini activities using the TI Inspire. And I think self-learning is very powerful, and TI Inspire really does a wonderful job of providing opportunities for students given the right platform. So I'm going to now move to the next set of questions. So I will there are 4 questions that I have chosen, especially to just highlight the use of the calculator. The first one was from one webinar, from a webinar that I attended. So this is, it could be a past paper question, but I haven't really found that out. But the following 3 are past paper questions. So this question obviously is a discrete random variable distribution here, and you want to find the value of k. A quick, this is what I advise my students. I say, first read the question, the 5 minutes that you have. Please make a mental note of what you have to do through the questions. So this is for a quick run through of questions. They will observe, oh, the value of k, and then you have to find the mean. So the value of k has to be substituted. These are the few mental notes that the students would hopefully make, and standard deviation. So in this case, and then you have a conditional probability question where again, you have to use the probabilities by substituting the value of k. So I find it really useful when we can define these variables, define k in this context here. So what I'm going to do is always for a new question, I strongly recommend the students use a new problem. Now, the way to get around getting problems, there are several ways. You could go to the document and you could do insert and you could do problem. That's one way to do it. And maybe I'll do this one for now. Since I have to define, you can either define on the list and spreadsheet, you can define in the graphs page, you can use the calculator. But since there is, so I'm going to use the calculator for now. And I'm going to say I've got to solve for k, and you see that this is a quadratic. So there are 2 ways. You can either use nsolve, or you could use polynomial tools. The disadvantage of nsolve is you have you get only one answer, you don't get the other answer. But in a question like this, where one answer is going to be a negative and the other answer is going to be positive, it really helps to use nsolve. But these are through practice. When students get enough practice, they realize the advantage of one over the other. So I'm going to use nsolve because you equate this to 1, and you would have the constant being negative. The value of c is going to be negative. We are going to end up with a positive and negative answer. You can also use tools, but I'm just going to show you an effective way of doing that. So if you look through this, we are going to say 8k squared plus 0.1k minus 5 minus 0.525 equals 0. For solving, you got to equal to 0 and define the value, the variable that you are going to solve for. So I go to menu, I go to algebra, and with effective use, students know it is 3-1. So, you know, with the continuous use of the TI Inspire, students can arrive really, you know, miraculously faster. And then I'm going to say it's 8k squared. I don't have to define. The other important feature of TI Inspire is that I can use any value for you know, any variable, any alphabet for the variable, and that's really handy. And I'm going to use k because students sometimes at the end of the question that students have to define k, sometimes they answer x is equal to, you know, and then you lose a mark. So this kind of really facilitates student work. And this is 8k squared plus 0.1k minus, because it is equal to 1 and you have to subtract it. So this is minus 0.525 equals 0, and you've got to solve for k. Now, you are not interested in the negative value, you're only interested in the positive value. So what I can do is force the calculator, or rather encourage the calculator to give you a positive value by, you know, using a condition such that, so if you see such that k is greater than 0. So I'm going to do k is greater than 0. So you really don't have to bother about negative answers because, you know, probability values have got to be greater than 0. So you do this and you press and you get 0.25, right? I also sometimes the use of fractions is really useful in probabilities, I found out. So we could do the same thing. I'm just going to repeat the step, but just show sometimes answers in fractions help. So I'm going to go up here, and you must know how easy it is to navigate, you know, just copy paste. And that really, you know, it's cumulative when you're solving because you save time really, and it really builds up to save a lot of time. So I'm going to press enter, and at this point I am going to do menu, and I'm going to, I need the answer. I'm sorry. Okay, you go to number and you go to approximate to fraction, and there's no particular need for this question, but sometimes for a question that I'm going to do later on, this is helpful. So I just, you know, at first point, you know, you can find it as 1/4 here. Find the mean of the distribution. Now here is where defining the variable. So now I'm going to define the variable, and you might see the value in doing so. Store it as k, right? And I'm going to press enter. I'm going to open another page here, a spreadsheet page here, and I'm going to, since this is a new problem, the values that I predefined as x and p really have no bearing on this document. You know, it really is not going to bother me. So I can redefine them as x and p because these are x values and p values. So I'm going to define that as x and define this as p. Okay, and these values are 0, 1, 2, 3. So I'm going to write them as 0, 1, 2, 3. And I'm not going to substitute value of k, not substitute the value of k to find actual values. What I'm really going to do is write those values here. And this is 2k squared. So 2 multiplied by, when k has already been defined, you really don't have to put the multiplication sign, but sometimes it doesn't work when you have two variables. So as a thumb rule, I just instruct my students to always use the multiplication sign. And
Ma'am,
yeah.
there's a question from a participant, Arif.
Yeah.
So he's asking, what steps do students need to write in exams?
So you can, so what students could do is just show, wait, have I kind of, just let me see, you know, might be. So this is what, so for this one, you would have to show that, you know, 0 times 0.475 plus 1 times 2 times k squared plus 2 times 0.1k plus 3 times, you know, yeah. But the advantage of doing this is this, I believe, was 0.1K. Arif, just you might see the value of doing so in just a minute. Okay, just give me a minute. I hope I've answered your question earlier. Whoops. Okay, so undo, right? I just take this opportunity to show undo. So this is 0.1K, and then this was 8K squared, 6K squared. So 6 multiplied by K squared, yeah, squared. Yeah. Right. Okay. And now that I've defined, now the reason if this was just the mean, I really didn't have to do this because it is possible it takes more time. But the question here, the following questions, if you have observed here, will use the value of K over and over again. And that is why I took a conscious decision of storing the value of K and using it as K here. So when I go here, I can go to menu, I can go to statistics and do stat calculations, one variable statistics, number of lists is 1. Now that I have stored here, the value of list is X, this is P. I go down using tab, I can go down, I need to enter first. Okay, and if you see here, I got my mean, which is 1.3, and I got my standard deviation as well, which is 1.38. So I kind of answered a couple questions in the same, 2 birds with 1 stone kind of thing, where I found the mean and standard deviation. So for your question, Arif, when you said what kind of working, it is 3 marks worth. So there is a method mark showing, and it is a calculator paper. So just the method to support your answer is good enough. So I would do some of these products and say find the value and say it is 1.3 as shown here. The mean is 1.3, and the standard deviation next, if you see, is a mark. So we've already kind of used technology to solve it, and that is why it is 1.38, right? And the next question as well, it says the probability. So this math, the work that you need to show, I will just emphasize here, right? So I need to kind of translate the language into mathematics here. And this, it says, find the probability that it is a value of 2, given that it is the X value is greater than 0. And if you see here, what I've done is, since I have already defined K, I can go back and I know it is a conditional probability. So it is 0.1K. I don't have to really substitute because I have found K, and this is 1 minus because it is greater than 0. And we've already figured that out, that it is 0.525. So it is 0.525 and press enter. So I think this one, the notation, the mathematical computation, like the values that you would use, and the final value should give you the mark. Okay, do I have a question?
There's a question, I think it's just repeated about the...
I can't hear you, John. Can't hear you well.
Can you hear me now?
Yes.
Is it okay? Sorry, there's just raining outside, so there's a lot of background noise.
Yeah.
Well, I just wanted to try and the questions about the working. Since it's a calculator paper, and throughout IB the rule is, if it's a calculator paper, even what you see or feed on the calculator,
yeah,
especially for AI, this is what we were told even at the workshop, that what you feed on the on your calculator, if you can. Even that is considered as working. So even if you have written the syntax as Mrs. Naik is showing, that's also going to be considered as working. So it's not that you have to show an algebraic way. If that's working, does not mean that you're doing it algebraically. I hope I'm clarifying that. It does not using the formula, the algebraic way. Even if you're showing the syntax, because calculators allowed, right? So that is what's specified in the workshops and in the question paper, that if it's a calculator paper, what you enter. So for instance, if you're using a graph as part of the answer, even if you do a sketch of the graph, That's what you're putting
Oh,
in the
yeah,
calculator. Using
definitely,
the calculator.
definitely.
So it's not necessarily an algebraic working of the formula that you need to do in addition or to substantiate what's already being done. Jalaj, any other views?
Yeah, no, same thing, exactly what you said. So Rajiv, what happens here, like in this question, to find the value of k, it is a 3 marks question. So examiner will be interested in just one thing, that if the like candidates have an idea to find the value of k, some of these probabilities should be 1. So if you're able to show somewhere that sigma p is equal to 1, hence
Yes.
k is equal to 0.25, that will be enough to get you 3 marks. There has to be some evidence that candidate knows that sum of probabilities is 1, hence k value is 0.25. If the candidate just writes k is equal to 0.25,
You'll get the accuracy mark, yeah, but you'll miss out on the method mark.
yes. So you may not get three full marks, but
Yeah.
the moment you write summation of p is equal to 1, or you show it using any other way, like John mentioned, using the graph or by any other mean, you
Yeah.
get full marks here.
Yeah.
Because it's a calculator paper.
Yes.
So algebraic work is not needed here.
And even if
Hopefully
you
you answered.
show that the expected value is the same as mean, right? That is also one of the ways of just using concepts from a different part of the syllabus to effectively show your understanding.
Absolutely.
You were saying something?
No, I just wanted to make sure that the question was answered. You know, I mean, both of them answered. Thank you. Yes, ma'am. Sorry, you can continue. I'm sorry.
Oh, yeah, sure. Thank you. Thank you, John and Jalaj, for clarifying. We'll move on to the next question. And here, you know, I've just raising the stakes a little bit for finding, you know, this is such a brilliant part in our presentation here, where there is a variable that is that is in the question, and NSPIRE really, I think is superior in this manner, because you can use a constant and you can use the variable, the x variable in the same stroke, if I may use, to solve for A. All right. So let's go through a quick question. This is a 13-mark question, and this is from a past paper. And you have the variable A here, and you could algebraically solve. But the point is that this is a calculator question. So obviously, use of technology is celebrated, is recognized, is acknowledged. So I think optimum use of the calculator, I hope to show in the next question. So show that. Well, a show that question really means that you've got to kind of arrive at the conclusion, not use the value of A to show that it holds true, right? So again, as a rule, always the next problem. So I'm going to move on, and I showed you a different way of getting to a problem. A problem is a new question done on a page that has no link to an earlier question. All right. If you add a page, that would be, so 2.1 and 2.2, 0.1, 0.2 are pages to problem set 2. I'm moving to 3. So I will need, so that one way was to go through documents. The other way is, you know, there are several ways. Since I'm using the emulator, I might just, you know, if you are teaching and you want to use this option, you can do insert here, right? And oops, yeah, okay, yeah. So you can, this is the problem that I've inserted. And now when I go to menu, this question, I'm going to use a calculator page here, and this is the calculator page, sorry. Okay, so this is the calculator page. Did I confuse anyone here? Getting on to a new problem and getting to a calculator page? If so, please let me know. When I'm doing my next problem, I can you know, showcase that there. So 3, and now, okay. So one way, if you've seen, I can even define this. And sometimes defining in earlier presentations, when Jalaj was presenting or John was presenting, they've shown really the importance of defining functions first, because you can use them across applications, especially in a calculus question or a long question or a trick question, where really you've got to use multiple applications. It's really useful. So I've done it in multiple, in different ways, and I'm going to show, you know, let's see how this works here. All right. So now, if you notice, the A is common, so actually I can factor the A out. It's an important part for on the part of the student to understand this, right? And it's so the probability of this of this continuous random variable is going to be equal to 1 when we just use these two pieces, these two bits of the hybrid function. So what I can do is I can so one way, so you get a method mark for recognizing that the probability, the sum or the total probability is equal to 1, or the area under the curve of these two functions itself is equal to 1, because this one is equal to 0, the third bit is equal to 0. So I am going to now go, let me do it a couple ways, and you can then people can share their comments. Right, so I'm going to go here, and I am understand that I've factored A. So all I'm left out with is 0 to 0.5. These are the bounds, and this is 3x because we are finding A. So when you are actually writing, this is what I mean. Let me just be a little bit specific if I wasn't earlier. Okay, so this is what I mean, right? So these two bits will equal to 1. This is an important part here, the method and the accuracy here. And A, I've dragged the A, I've factored the A out because I'm solving for A. So all I have to do is really put this function in here. Right, so it is 3x, if you notice, it is 3x. Okay, just a moment. Yeah, and dx. Okay, okay, plus, and so I will take this opportunity to show that I can kind of go back, undo a function. I actually have to get out of this function, add, and that's why, you know, I kind of struggled through here because I had to get out of the function, and I can kind of do the same thing here. I can copy this, and it's really so handy here. This goes from 0.5 to 2 because the domain is from 0.5 to 2. And the function is 2 minus x. So I'm going to just change that, 2 minus x, right? And I equate this, and this is equal to 1.5, right? And the next step, as you see here, if you've noticed, in my working, I have shown you that when A multiplied by 3 by 2 is equal to 1, and that is why how you arrived at the answer that A equals 2/3, right? The other way, okay? So Jalet and John and any other participants, if you have any comments, let me just show this way. I could have gone. So this is where I find the NSPIRE a little superior. I go to algebra. I'm doing the same thing, numerical solve, and now I am doing this with A, okay, multiplied by, and I am going to kind of equate this here, okay, and now I am solving it. So I'm making sure I'm out of the function. Yeah, okay, equal to 1, okay, and I'm solving for A. I'm solving for A, so it is comma A. This seems to come in the way. Comma A. So now if you notice here, I've already used the variable as x, but now I've not defined A, but I'm still using the A as a value to be found. And I kind of solve. Oops. This should not have happened. So maybe I typed something wrong, but that too works. I'll get back to that one. So even if I do the value with A, you can get a value of 2/3. Let me try that again. So I went to menu, I went to algebra, and numerical solve, value of A multiplied by okay, maybe this has to be in brackets. Yeah, and because A is common to both, equals to 1, and I'm solving for A, right? So that's how I got. So the earlier part, I hadn't used brackets, and this is a teaching, teachable moment, and it's 2/3. So now I could have here. So this is where it can, since your answer is in fractions, well, most students would know this is 2/3. But what I could have done was done this, and in the first place, before pressing enter, I could have gone to menu, done the gone to menu, gone to number, and approximate to fraction, and done this, and I've gotten my 2/3, right? So Jalaj, do you think this is, or John, or anybody else, do you think this is a credible way of showing work?
Yes,
In a
it is
yeah,
beautifully.
Yeah. So see, this really, I mean, it kind of relaxes the students when they're working on, when they know they've got a powerful way of showing their understanding. We'll move on to the next part, which is okay, and the beauty in the reason I chose this question is because of part C. A 7-mark question, if it can be done in a couple of minutes, what else would the students really want? So now this is less than 1. The x value is less than 1. So also the copying operation really is helpful, because all I have to do is find this one, right? So I'm going to copy here and paste here, right? And instead of 2, I just really want 1. Now, mind you, that the a value, that is, I should have stored the a value. So let me just, I'm sorry about this. Let me just cut that out. So let me delete this. Okay, I'm going to store the value. I'm all into storing today. So, and I'm going to call it a, and oops, sorry, sometimes I've clumsy fingers. And yeah, answer, you store it here as a, and I'm going to keep it here. And now all you have to do is actually, the a is, right? We all want to do this one here until here. And I'm going to find the value, but this is x is only until 1, less than 1. So I'm going to change this to 1, right? So this is what the question asks. Let's go back to the question. It says, find the probability that x is less than 1. So it is from 0 to 1. And this is what I've already defined the value of a, and I press enter, and I get 2/3 again. So the answer is 2/3, because this is equal to 1. This is equal to 1. A is equal to 2/3. So 2/3 times 1 is, you could have alternatively, you could have also shown this, not use the value, store the value of a, and I could have gone this, and see, this is equal to 1. That is why a times 1 is equal to a, and that is why it is 2/3. Now, the next part is interesting, right? Because it says this, the probability here is equal to twice the probability of this function. And the function is, this is when the values of s lie between 0.25 and 0.4. And there's actually a purpose here, because if you see, twice of 0.25 is 0.5. So actually this part, this latter part, only is with regards to the 2 minus x, the second hybrid part, right? So what I'm going to do, so this is what I have to show, right? So from when s lies from, when the value of x lies from s to 0.8, the left hand side will include both bits, the first part and the second part, because s value lies between 0.25 to 0.4. So this one, so this is what I will, let us see if it works. And it is an end solve, because you have to find the value of s. So I'm going to, please stop me if after I finish this question, if there are any questions. So I'm going to do solve. Okay, so going to menu, going to algebra, and by now you would have known that it is 3-1. So menu, algebra, which is 3 and 1, right? So, and solve. Now, what do we have to do? You this entire bit here, right? This probability, when the value of this is S, because the first part of the function include both bits, the 3x and the A. I factored the A. See, I have not used 2/3, so I'm really saving up on my on my time to type out these things. The A is a factor here, equals to twice. It said twice, so twice times. Now this part, this time, it is only this function, because the S value lies from 0.25 to 4. And this part of the equation is 2S. So this has got to be 2S, and this is 0.8. Let us go back to the question just a bit. Let me just solve this. Let me just finish typing this. 0.8. And let us see if we have kind of, oh, we forgot the A, didn't we? Because we need the A. So if you see, so let's go back to the question here. So it says the probability that value of X lies between S to 0.8. And for this part, I need to use both these bits hybrid functions, is equal to 2 times the probability of X value from 2S. Now 2S is, we've already moved into the next domain, which is 0.5 to 0.4. So 0.5 and 0.4. So it is 0.8 here, right? And now I have to kind of, right? I have to solve. So I've got to define. If you see, I've got to define. So I need a comma. What am I finding? I'm solving for S, right? And yeah, so let me just show you what I have done from left to right again. So we kind of get the entire okay, here. Okay, so it's N solve 8 times. Now, if you realize I could have canceled the A, right? We really, if you do that, and then I'm going to press enter. So here again, there is a miss part on my part, as you say, you've got to be really careful about that. I'm just going to do undo. I take these opportunities to show you where I've gone wrong, right? So I'm going to just write X here. I don't know why my fingers are really clumsy today, so I'm sorry about that. Excuse me for that one, please. Yeah. So I'm going to write 2S here as it in the question, 2S, 0.8. And now I have to step out of the function. If you see a larger, note, take the larger note of the bar there, equals, because now I'm not kind of interfering with the X, with the X there, equals, oh, not equals, so comma, and now I'm solving for S, okay? And now I do this, so I get 0.274. Now it is a 7-mark question. Obviously, I messed up here and that it took a few minutes. But now what, a 7-mark question, how do we kind of justify? Because you've really shown what you're understanding through your working. You really showed that the left-hand side, which should earn you a method mark and an accuracy mark for spelling out those 2 bits of the equation and then solving for S. So having this, since this is a calculator paper, the algebraic working is really long. And this is how I think students can capitalize on the use of the calculator. Any comments? So I'll just show through this question here. I'll just show you, yeah. So this is what I have done here in the blue part. I think this is important to show bits. This is the working that I think we should encourage students to show. And then this is the part, I don't want to kind of algebraically work through this, because I can show it through my working here that it is 0.274. Yeah. Any questions, please?
Yeah, they only concerned about the 7 marks. I mean, I think that's been the bigger question today about people whether marks is justified for the work that is, the calculated work that is given.
Yeah, because it doesn't say show that, John. If it was, it should show that, then you were really expected to do the algebraic work. From my experience, I think if you really, because this really puts your understanding to test, showing that the 2s really only concerns this part of the function, and then you have this 2 bit equal to.
Is this a paper 4 or a paper 6
paper
question?
2. Paper 2.
Paper 2. Okay. I was wondering because there was not much of I was going to ask earlier on whether it was a 2 or a 4 because in some of the questions that you were scrolling, I didn't see much of interpretation as much as solving. So then definitely for those of you, like Marie also asked the same question right now, Rajiv, and definitely I would say your calculator work, like I say, I'm reiterating that if it's a 2, paper 2, then that's good enough, even if it's 7.
Yeah,
okay?
Even if it's 7, yeah.
So I hope that, because now I just wanted to clarify that too. I mean, if anyone has any other thoughts, please feel free to share. Lovely to hear this because question has been coming again and again, like how much work the students have to show. And by work, I think we're clarifying work as an algebraic method of actually substituting, as opposed to what you're using the calculator, which method you're using, which you can report it on paper and show it on paper. The expression that you entered the calculator and what the calculator is giving, these integrals that Mrs. Naik has shown. That is also work. So it doesn't have to be that you literally have integrated or using any other algebraic method. You can report what you've seen on the calculator, what you've entered on the calculator. That is work. And if it's paper 2, you should get your 7 marks.
So Jalaj, please help me out here if you think it's any different here. So I just put this 2 bits explicitly. This is what x lies between s and 0.8 means, because you have got a method mark and you've got 2 accuracy marks for really spelling it out, and then you have a method mark here also for getting the right hand part correct.
Exactly.
So, yeah, so this can be done because as students are thinking, this is what they would be thinking. So your thinking has been converted into your work. So I think students could use a minute to really spell it out and then put it together, because when you equate kind of things, you have another solving mark, and then you have the final answer, right?
Mm-hmm.
Yeah.
And when it comes to method marks, usually it's an attempt. For any valid attempt, students get full marks.
Yes, I agree.
So like in the left-hand side, for the identification that x between s and 0.8 is made up of 2 integrals, m1 and a1, 2 marks for accuracy. In the right-hand side, again, 3 marks or 2 marks for accuracy and 1 mark for method. And any valid attempt to solve is 1 mark. I think 7 marks are justified for this.
So if we kind of train our students to think through this, effective show time management is such a big issue for many students. I think we can kind of train them to use technology to the best of their ability, right? It's almost 3:55. Should I continue with the next question?
There was one question I don't understand from Pooja. It says 2 out of 3 on the left side. What does it say? Is it a question or is it
the questions?
It's on the chat.
Yeah, where did I lose the chat? I don't know.
2/3 on the left side of equation blue.
Hasan, can you unmute Mr. Mahesh Reddy?
Oh, Mr. Mahesh, you can unmute yourself and you can speak now.
Sorry, sir, by mistake.
Oh, okay, no issues.
Yeah, it's here.
Okay. Pooja writes 2/3 on the left side of the equation in blue color. Is it to be?
Oh, that's the value of A. So what I've done is I've already kind of Have I done the mistake here? It's possible. Oh, no, I haven't, because here I've already kind of multiplied the 3 by 2/3, and that is how you ended up with a 2x. And this way here, I have not factored the 2/3. So I did the 2/3 here. Sorry, if that was confusing. So if you see here, look at the work here on the worksheet here. The 2/3 is common, so you will see a 3x here. But if you look here, I've already kind of multiplied the 2/3 to the first integral, and that is why it is the 2x. But the second part I haven't, so the 2/3 has been multiplied. So I did a little bit of calculation here on the first integral, but not the second. I don't know why I did that, but yeah, I'm sorry if that is confusing. And actually, I should have shown with the a as I've shown here. So I think the beauty of this working is that you've never you continued the use of a, and you could have really shown sophistication. Students could have shown a little bit of sophistication by not using a, because a is common to both parts, and that's good good way of a good demonstration of understanding as well. Yeah, so it is almost 4 p.m. My next question is going to take long. So Jalad, I will, I'll leave it up to you for me to continue now, or you want to take the next bit and I can show my question at the end if there is time. What do you want me to do, Jalad?
Actually, everyone is enjoying it. So we can ask participants, would they like to go with the paper 2 questions or paper 3 question? If they would like to have an experience of paper 3 question, I can continue. Otherwise, you may continue. So, Arif sir, we got 1 vote for paper 3. Okay, so paper 3, please. Paper 3, please. Okay, so Shraddha.
Yeah, I will stop sharing. I'll stop sharing.
But we were really enjoying it. So
yeah, definitely. If there is time, or we can have another. Yeah. Oh my God, you've taken a poll. So that's great. Oh, the other thing I wanted to share was before I stop sharing, can I just quickly share something?
Yes, ma'am, you can.
Yeah. Okay. So what I want you to want to share with you is this one here. As I went into this part, am I sharing? I think I'm sharing, right?
Yep.
Yeah. Okay. Yeah. So here, if you see here, to just check a student's understanding. This is what one of you, either John and or Jalaj or Hassan, could then just add on to this one. It is a quick poll. Now I have not used the navigation that TI Inspire promotes because of its use, because of its a teaching strategy, teaching and assessing strategy. But I find it's used through this question. So what I've done right after I have kind of showcased the normal distribution, if I want to do a quick formative assessment, a quick check on student understanding, I can just set this question here. So what I did was I went to insert, and when you do insert, you go down to question. And for a question, you have different things that you can choose from. I chose A, B, C, D. And what I did was, it is, through years of experience, I've noticed the students really stumble through this when it is area to the left and area to the right. And just to clarify, to kind of assess their understanding, these kind of questions really help. This also assesses kind of rounding errors, Sometimes students lose a couple marks just for not correct, accurate rounding. And this kind of tells. So this is one thing that I wanted to share. So Jalaj, on to you next.
Thank you. Hassan, could you please share that question with everyone?
Yeah, so I'll share on the chat so that they can download it from there.
Hi, good evening, everyone, and thank you all for joining. Today we'll discuss a paper 3 question from MAI higher level, and this is solely based upon probability and statistics. There will be analysis, so using hypothesis testing, some decision making, doing some modeling here. So we will be experiencing everything in this question. So many things, I would say. So I will be showing you question, but it's great if you could open that question in your browser also, so that we can work together. Okay, so let me share my screen. I hope it's sharing. Is it sharing?
Yes, we can see the browser, the Google Chrome.
Okay, great. So let's move on. One moment. I'll stop my video because of the bandwidth. I may get disconnected, so I don't want this to happen. So I'll keep my video off. Okay, so let's move on. And let me also open this question, which is right here. So let's read it together for next minute or two, and then we'll start solving it. This is from May 20, MAIHL paper 3. This is first question. So this question is about Juliet, who is a sociologist who wants to investigate if income affects happiness among doctors. This question asks you to review Juliet's method and conclusions. So Juliet obtains a list of email addresses of doctors who work in her city. She contacted them and asked them to fill in an anonymous questionnaire, and so on and so forth. So this is the response which is given in this table, response from A to K. And when the annual income is in $65,000 per annum to 1,236,789, and happiness score is also given. So now the question starts here. Number one, describe one way in which okay, we need to read few more important things here. Participants were asked to state their actual income and to respond to a set of questions. The responses were used to determine the score out of 100. Now this is very important here. Out of 415 doctors on the list, 11 replied. So this we will use to answer the first part of the question. So part is describe one way. Now there are when it comes to reliability, there are two things. One is validity and one is reliability. So in statistics, we all know that when it comes to reliability, reliability depends on the consistency. So she can this test result can be consistent for the reliability. So Juliet can improve her reliability by doing some repeated surveys. She could do more surveys, and if she gets a similar result, it okay, John or Shraddha, could you please check if there is anything in the chat which should be answered immediately? Otherwise, we can take up.
Sure.
Thanks. So part A, question number one, describe one way in which Juliet could improve the reliability by conducting more such surveys, by repeating her surveys. Second is describe one criticism that can be made about the validity of Juliet's investigation. Now, if you see here, only 11 doctors out of 415 doctors replied this survey. And maybe they didn't reply it. Maybe the nurse, secretary, or some helper, somebody else replied. So we are not sure about the level of honesty involved in these responses. And validity depends upon the accuracy of the result. So one criticism could be the honesty level involved in this survey or this response. John, did you say anything?
No, not at all.
Okay, great. Let's carry on. So Juliet's results are summarized in the following table. So this is a table. Juliet classifies response K as an outlier and removes it from the data. Suggest one possible justification for her decision to remove it. This is a 1 mark question. Actually, it is. I typed this question again since I got a scanned copy, and that scan was not a good scan. It was just a picture. So I typed it again. So I forgot to put 1. This was a 1 mark question. Now, for outlier, we can do it in 2 ways. Either you actually find outlier. If it is the upper outlier, then one upper quartile plus 1.5 times interquartile range. And for lower one, it's lower quartile minus 1.5 times interquartile range. Now, considering that it is just 1 mark question. So either you could, since we will be using calculator for this questions, and all these values will be inserted in the calculator. So either you can find the quartiles, lower quartile, upper quartile, interquartile range, and you can check whether it is justified to consider this K, that is 121,236,000 as an outlier or no. Otherwise, if you just see, you could also write all these doctors, they have incomes either in 5 digits or in 6 digits. Considering the context of the question, if the annual income goes into 7 digits,
Yeah.
then it could be like this statement can be written as justification to justify. So you can say like annual income of each doctor is either in 5 digits or in 6 digits, and income in response K is unusually high in the context of income in US dollars, which is 9 digits. So this can be ignored. Or you can find the upper quartile, lower quartile, and find the statement interquartile range and check it like mathematically, and give you a decision to justify this. For the remaining 10 responses in the table, Juliet calculates the mean happiness score to be 52.5. Calculate the mean annual income for these remaining responses. So first thing what we can do is we can insert these values in the calculator. So let's go to the calculator. Where is the calculator? Here is our calculator. So open a new page, and this time what kind of page will be needed? You can either do Control I or you can do through doc. So this time we will use a new list and spreadsheet page, which I have already opened here. So, and I have already entered the values so that we can save some time. So these are the values. 65,000. You can define these cells, but I didn't define, just like it. I was being lazy. But you can always define that this is first one from the list. If we see this is annual income. So, and second one is happiness score. So you can do that. Happiness score. And there you go. Okay, now, one moment. It's evening here, so I have to turn on the lights. Okay, so once you insert these values, after inserting these values, let's go back and read the question. The question says, for the remaining 10 responses in the table, Juliet calculates the mean happiness score to be 52.5. Calculate the mean annual income for the remaining responses. This is 2 marks question. And determine the value of R, Pearson's product moment correlation coefficient, for these remaining responses. So when we use the calculator, you have already inserted the value. So this is now it's time to do some calculations, and everything here is here in the lighthouse. As John says, your menu is your lighthouse. So if you're lost, go to the lighthouse. So we go to the stats calculation. So what sort of calculation do we need to do here? We will be doing 2 variable statistic. There you go. Where is your X list? Your X list is in A1. Either you can put in A1 or you can define from here, income or HS. So I can simply do income here, and the Y list is happiness score. And your result can be here, and enter. So once you enter, everything is here. So your X bar is 90,200 or mean, and Y bar is 52.5, which was given in the question. So calculate the mean annual income for these remaining responses. 2 marks done. So you just have to write like using the calculator, and this is your answer. Determine the value of R. Pearson's product movement correlation coefficient. Again, it's 2 marks. So just read the value from here and just scroll down. This is 0.55772. So you can write it as 0.558 to 3 significant figures. This was question number C, part 2. Now, Juliet decides to carry out a hypothesis test on the correlation coefficient to investigate whether increased annual income is associated with the greater happiness. State why the hypothesis test should be one-tailed, 1 mark question, and state the null and alternate hypothesis for this test. Juliet decides to carry out a hypothesis test on the correlation coefficient to investigate whether increased annual income is associated with greater happiness. So your answer lies here. Your answer is whether, what are we testing for? Whether your annual income is associated with greater happiness. So answer to the next part is, if you see here, we are testing the income, increase in income. Increase means increment in the income with greater happiness. So more the income, happier you are. So we can say change in income and happiness are in the same direction, or we can say positive correlation. So any of these you could write, which can justify that it is a one-tailed test. So either you can say like increase in income with greater happiness, or they're in the same direction, or positive correlation. So any of these things will do. So it is just a 1 mark question. So state why this be one-tailed, because we are testing them both in the same direction. So this could be great to do. Part 2, state the null and alternate hypothesis, 2 marks. Usually they give 1 mark each for null and for alternate hypothesis. And as we all know that null hypothesis is always like opposes the changes. So this is null hypothesis will be the rho is equal to 0. That is the population correlation will be 0. And the alternate hypothesis will be the population correlation, that is rho is more than 0. So rho is equal to 0 and rho is more than 0. The critical value for this test at 5% significant level is 0.549. Juliet assumes that the population is bivariate normal. Bivariate normal. So determine whether there is a significance evidence of a positive correlation between the annual income and happiness. Justify your answer. Again, this is only 2 marks question. So we don't have to spend too much of time and space here. So let's read this again. The critical value is 5%. Juliet assumed that the population is bivariate normal. Determine whether there is a significant evidence of a positive correlation between annual income and happiness. Justify your answer. So see out here, Juliet assumes that the population is bivariate and it is a one-tailed test. So we can use T distribution here. And in this T distribution, positive correlation. Okay, so we can do everything by the calculator, but I would like to discuss a bit of it on the board also, like this one. Let me show you. Okay, can you all see my my board?
Yes, Jalaj, we can see.
Lovely. Okay, so now since Juliet assumes that the population is bivariate normal, so when you do one-tailed test, then the test statistic will follow a T distribution. And what will be the p-value here? P-value will be here that the test statistic is approaching away. So if we look here, 0 at 5%, significant level. So if this is your, see, we can do this in 2 ways. Either we can talk in terms of the p-value, or we can talk with the help of the test statistic. Where is it lying? Is it lying in the critical region or lying in the acceptance region? So test statistic here will be T is equal to, this is already given in the question, right? the test, the critical value is given here. Sorry, I couldn't hear. Okay. Sorry, the critical value is 0.549. So 0.549. So anything which is more than 0.549 will lie in the rejection region, and we will reject it. And in out here, the t statistic is r square root of n minus 2 divided by square root of 1 minus r squared. And r we just saw was 0.557558 we wrote, so 0.558 square root of n minus 2. We are considering only 10 samples, so 10 minus 2 divided by square root of 1 minus r squared. So I'll just keep it 1 minus r squared, where r value is same as the previous value. Now, when you simplify this, I calculated it was coming 1.90. So if you see 1.90, where is it lying? It is lying somewhere here, which is in the rejection region. So we have sufficient evidence to reject the null hypothesis, which supports that happiness is not associated with income. And so we can write here like H naught was rho is equal to 0, that happiness is not associated with the income. And H1, the alternate hypothesis is rho is more than 0, that happiness and income have positive association or positive correlation. So you can approach it either this way. And if you like to see p-value approach, what happens in p-value approach? For the same question, if we see in the p-value approach, how will this look like? So this is 0, and we are rejecting 5%. So we are rejecting 0.55%. So, and how do we find p-value out here? To find p-value, this test statistic is very, very important. So p-value will be probability that t is more than or equal to 1.90. So this, when we find 1.90, you can use the calculator to find this. How do we do this? Just use TCDF. So where is our TCDF? TCDF is here. We can go to our calculator page, menu. You can either go through statistic or through probability. Go to distribution, TCDF, your lower bound. Now here we are looking for more than, what was this value? 1.90. So this can be 1.90, and your upper bound, put any big value. And what is the degree of freedom here? Degree of freedom is always, in this case, it will be 10 n minus 2, that is 8. And okay, so your answer is 0.0469. 0.0469. So at 5%, let's go, let me go back to my, this one.
Jalaj, we have a question in the chat, like, is it necessary by t-test? Can we do by chi-square test?
See, chi-square test, we have actually, either we do it by doing test of independence, or second is goodness of fit, right? And if you see here, the nature of the question is asking you, if I read the question again, the population is determined whether there's a significant evidence of a positive correlation between annual income and happiness. So since we are looking at, we are testing any, okay, so you mean this dependence in this one. Yeah, but like it is bivariate normal, so we usually use t-test. So that is why I took t-test here. So Cynthia, John, what do you think? Can we use chi-squared here?
Can you hear me, or have I muted myself?
Yeah, John, we can hear.
Yeah, carry on.
I suppose you could use. I just wanted to know because I think a couple of times Hassan said my voice is. I suppose you could use, but then
Yeah, it is low, not as usually like strong enough, but we can hear you.
Okay, I was just wondering. I could use. Could still use. I was just trying to, because when I saw the comment, I was just actually trying to do it on my own, but I'm not so comfortable with the theory which you are talking about. It's used only for the goodness of fit, and that you cannot use this in this case. Is there something like that which says?
0469. I haven't tried actually, so maybe
I was actually, even when I saw the comment, I was actually going with that. But there was one more question on the comment, Jalaj. It was about the 5% P. I think Arif said something that. Did you say something like H naught has to be rejected or something? I because by the time you'd gone, I was looking at the chat.
Did I say?
Did you say something where null hypothesis has to be rejected or something? I did not understand.
If I said, comment. Then I'm sorry for that. But
no, okay.
Right. This null hypothesis, yeah, null hypothesis should be rejected.
Okay.
Did I say that?
Yeah. You want to comment on that? There was Arif who said something like, or Arif, do you want to clarify your question?
Okay. What is that? Let me also read it.
If it's a little ways ahead because now people are talking about.
Go back to this one. P value is more than 0. Except.
Great.
Did I say P value is more than? No. See what we were discussing. When the P when P value is more than 5%, we have to accept H naught. Let me go back to my notes and see what I did here. I think we were talking about the test statistic, not the P value. Yeah. See here, we are using two approaches. If you see, this is about the test statistic. This is your tolerance point, or say critical point. Anything more than this will be rejected. So 0.54 up to 0.549 we will accept. So going back to the theory, basic theory of hypothesis testing, ideally it should be 0. The value of R should be 0, ideally. Okay, that is your null hypothesis, but practically it is not 0. So till what point can we tolerate? So that is the critical point. So when it is up to 0.549, we can tolerate that the value. But after 0.549, we have to reject the value of R. So what we calculated here, if you see on the screen, this is 1.90. The test statistic is coming 1.90. And that 1.90 is lying somewhere here, which is in the where rejection area, right, in the critical area. So it means we have to reject H naught and we have to accept H1, that there is a positive association between which happiness and income have positive correlation. Okay, this we are not.
I've asked Marie to be unmuted. If Marie can just add something to what the others were also discussing. Marie, go ahead.
Regarding the chi-square test, chi-square test is for, first, is categorical data. So if the categorical data, if there is association, right, then we test if there is association for the categorical data, that's one thing. And another use of chi-square is goodness of fit, right? And then if it is goodness of fit, and the question indicate that it will be goodness of fit. So chi-square is clear, it's not relevant to chi-square in this case. Yeah. So that's one thing.
Okay, thank you for that.
Yeah. That is good to make it clear, because that's one of the students' common confusion too. Because they love chi-square. It's like, you know, for them it is magic. You put just like in the matrix and everything turns out to be like, you know, on the calculator. But it is not. It is positive correlation coefficient like testing, and that's immediately going to t-test.
Great. Thanks, Mary. And I would like to acknowledge here that for this paper, me and Mary, we collaborated and we worked together to like solve this paper, because we don't know where the mark scheme. So we just worked together and we created the mark scheme ourselves. Thanks, Mary, for this clarification. Shall we continue? Shall we continue?
Yeah, Jalaj, you continue, please.
Okay,
No question.
so this one, the critical value. So determine whether there's significant evidence of a positive correlation between annual income and hypothesis. Justify your answer. Yes, there is a significant evidence. So at 5% significance level, the critical value is 0.549. So all this we saw. So we can say, hence we have enough evidence to reject the null hypothesis and accept the alternate hypothesis that there is an association between income and happiness. Okay, and after this, I'll share this mark scheme and the solution, how to do this using the calculator step by step. So you will have access to this soon. Okay, moving on. Part D, we are in part D. Yes, moving on to part E. Juliet wants to create a model to predict how changing annual income might affect happiness score. To do this, she assumes that annual income in dollars, X dollars, is the independent variable and the happiness score Y is the dependent variable. She first considers a linear model of the form Y is equal to X plus B. Use Juliet's data to find the value of A and B. Interpret referring to income and happiness, what is the value of A represents. Now, if you see here, when you go back in this one, we already calculated this part in our previous working. So moving on, did we calculate? Or is this? We did not, I think. So what we can do is we can calculate now. Once again, we go back and I think we did. One moment. This one, X square and AB sigma X, Y, R, minimum, maximum, Y, median, 6. Okay, never mind. Let's go back to menu, go to stats and stats calculation. Now we are looking at the linear regression. So go to linear regression. Your X list is income. Your Y list is happiness score. Frequency list is this. Go to E and okay. So there you go. Yeah, it is here on top. Actually, I missed it. Okay, so it is like this. 1, 2, yeah. So when you write it as Y is equal to mx plus A, this is M value, so which is actually 1.2584 blah and so on, time 10 raised to the power of -4. So if you write this as decimal, this will be 0.000126. And the B value out here is 41.149. So you can write as 41.1, or you can write this, keep the same value because, yeah, so you need to write values of A and B, so 3 significant figures. So this is directly from here, from the calculator. Then the next part of the question is, this was just 1 mark, so you can just write from the calculator. Part 2 is interpret referring to income and happiness. What is the value of A represents? So this is Y is equal to AX plus B, like MX plus C. So obviously this M value, A value represents the gradient of the regression line. And if you see in y is equal to mx plus c, gradient represents the increase or decrease for the unit change in the variable. So in this context, this a value represents, so it signifies the increase in the happiness score for a unit change in the income. So again, it was a 1 mark question. So you can just write like anything that can justify it. Then Juliet then considers the quadratic model of the form cx squared plus dx plus e. So for the quadratic model, again, we have to, let's go back to the menu. For the quadratic model, go back to menu and go to statistics. And this time we'll go to quadratic regression. And in quadratic regression, your X list is income, your Y list is happiness score. And if you want, you can write like A and B also here and save this to F2. Frequency list is 1. Anything else we need to write here? No. So let's go. So when you do this, this is your quadratic model. If you see here, so in this quadratic model, your A value is negative. It's a very small value. So this is negative 2.06 times 10 raised to the power of 9. Your B value, A means in the context of the question, it says cx squared dx plus E. So C is negative 2.06 times 10 raised to the power of 9. Your D value is 0.000705 and your E value is 12.587, so 12.6, let's say 12.6. Okay, going back, next part of the question, determine whether there's, okay, this was done, this is done. So
Jalaj, hello Jalaj.
Yep.
Am I audible?
Yes, go ahead.
Mr. Arif and Mr. Anjan has raised their hands.
Okay.
Can we, Hassan, please unmute Arif.
Yeah, Arif, go ahead.
Mr. Arif, you can talk now. Okay, we can give the chance to Mr. Anjan. Anjan?
No, I'll ask a little later. It's okay with me right now. Please carry on.
Okay, great. Let's finish it, then we will discuss.
Yes, Jalaj, please continue.
Okay, so from here we have C, A, B, C. Here is C, D, and F of the question, because it reads, then she considers the quadratic model in the form cx squared dx plus E. So find the value of C, of D, and of E. Again, it was a 1 mark question. So just read from your calculator and write it down. Then it says find the coefficient of determination for each of the models she considers. Again, 2 marks question. So we know that the coefficient of determination is R squared, so which is 0.65914 for the quadratic model. And when it comes to linear model, it was 0.31105. So we can write the coefficients of determination. R squared for linear model is 0.311. And that for the quadratic is 0.659. Next part of the question. Again, 1 mark, hence compare the models. When they say compare, contrast, so compare means they usually ask which is a better model. So as we all know that bigger R squared value is always preferred. So we can say since R squared of quadratic is more than R squared of linear, so quadratic model will be a better model in the given context. Moving on, next part of the question is, Juliet decides to use the coefficient of determination to choose between these 2 models. Comment on the validity of her decision. So for this, like again, it is a 1 mark question, so we don't have to give in like long detail, but we can always go back to the definition of coefficient of correlation. So basically when coefficient of determination. So when the coefficient of determination is 31.1% for the linear model, it means 31.1% of the points are likely to lie on the model, or 31.1% of the points, data points, will follow this rule, where the coefficient of determination for the quadratic model is 659, 0.659. So around 66% of the points, data points, will follow this quadratic model. So validity, when she decides to choose between these two models, so I think when she selects quadratic model, this will be a good decision to choose. So 1 mark, I think this will be enough to write. After presenting the results of her investigation, a colleague questions whether Juliet's sample is representative of all doctors in the city. A report states that the mean annual income of doctors in the city is, it should be dollars actually. Dollar, please change it to dollars. It's my typo. So $80,000. Juliet decides to carry out a test to determine whether her sample could realistically be taken from a population with a mean of $80,000. So part F, part 1 is state the name of test which Juliet should use, and state the null and alternate hypothesis and perform the test at 5% significant level. So again, like we do not have a standard deviation. We just have this thing, population mean. So I think t-test will be an ideal test here. So to test whether Juliet's sample is taken from the population with mean 80,000, she can do one sample t-test, and state the name of test, 1 mark question. So just one sample t-test, and state the null and alternate hypothesis. So your null hypothesis could be mu is equal to population mean, mu is equal to 80,000, and from this one, so population mean of the sample taken. So mu is equal to 80,000 will be your null hypothesis, and your alternate hypothesis, it doesn't say whether it is more than 80,000 or less than 80,000. So we have to go with the two-tailed test. So your alternate hypothesis here will be H1 mu is not equal to 80,000. And the sample mean out here for this. So, okay, so this is 1 mark. So null hypothesis and alternate hypothesis will be H naught is mu 80,000, H1 is mu is not equal to 80,000. So later this will be a two-tailed test. In this case, your sample mean, we found mean in first part, it was 90,200. So I think it was at 90,200. That was for here, yeah, 90,200. So this will be the sample mean to calculate the test statistic, and degree of freedom here will be n-1 for this t-test. So 10 minus 1 is 9. And out here, remember that since the population standard deviation is not given, so we need to take unbiased estimation of the population standard deviation. And then the test statistic here will be x bar minus mu upon Sn minus 1 over square root of n. That because we are doing this for, this is sampling distribution of mean. So, and we'll find the p-value here. P-value will be 2 times your test statistic is approaching away, and then we'll find the critical value. So we can do this in different ways. So let's see how do we use the calculator effectively here. Okay, so in this one, I'll go back to here and menu. And we out here in menu, we will go to statistics. And here we are doing, of course, the test. So is it here? Yes, set. This is the test, and we'll do a t-test here. And our input method, is it data or stats? We have data listed, so we can use the data. Now remember, it is one sample t-test, right? So we just have to use the data for the income, not for the happiness score. So when we do this, mu naught is your population mean. So assume to be 80,000. So we can put 80,000 here. And where is the list? The list was in, I think, A, or say income, you can say. And the frequency is 1. And what is your alternate hypothesis? You can set it to more than, less than, or not equal to. In this our case, it is not equal to. So we will put not equal to and okay. So if we do this, we see that here the t value is 0.5279 and the p value is 0.6103. So when 0 point, yeah, so we can see that 5%, if you test at the 5% significant level, then we have enough evidence to accept, since p-value is more than the significant level. So where is our this thing lying? Test statistic. It will be lying in the acceptance region, right? So we will accept H naught. So we have sufficient evidence to accept the null hypothesis that the sample has been taken from a population whose mean is $80,000. So I think this was the last part of the question. State, yeah. So all these questions were taken from May 21. So I have acknowledged IBO for this one. And in a minute, I'm going to share the solution mark scheme, we can say here with Hassan. So Hassan, do you mind sharing it with all the participants, please?
Yeah, wait.
Yeah, one moment. Yeah, let me share it with you first. So this is the solution and it goes here. So you will see it in your chat. So here I stopped sharing and you're most welcome to discuss any question, any doubts, anything, or any comments, Shraddha, John, if you like to contribute anything else at this point.
Anjan sir, if you have to say something.
I quite liked the session actually. Personally, I think both the sessions were quite interesting for me. And as a school, we still haven't started teaching AI. So I'm also building up the understanding of the AI curriculum. So I would personally say that I quite enjoyed both the sessions today. Thank you.
Thank you. John, I have shared that file with you. So if you could please share it with participants.
With me?
Anjan, I
Jalaj.
think that you
Hassan, I have shared with Hassan, sorry.
Oh, Hassan, sorry.
I personally think you explaining the question and supporting all the working on the whiteboard, and then alternating it with the use of the calculator, I think would have clarified a lot of questions, because you'd go back and forth and just highlight the points. So I think it was really a well done question.
So the one question from Pooja, Jalaj, if you want to answer that question about the tailed, take a look at it in the comment. Or if you can unmute her, then that'll be good.
Yeah, sure.
Hassan, you can unmute everyone. So one by one, when they raise their hands and they can get their chance to talk.
Okay, so Pooja asked, can you clarify one-tailed and two-tailed again? I meant when is it one-tailed and when it is two? Again, I know. If you don't mind, of course, we can always discuss it. So Pooja, like it all depends upon the question. Whenever we do hypothesis testing, we do hypothesis testing when we are not happy with the claim of the population. When population claims something and you have your doubts, then you do hypothesis testing, right? So whenever you test anything, then we have to read the question very carefully. For example, you say you bought a new iPhone and new phone, sorry, I won't take any name. You bought a new phone and the company claims that without charging, that phone can go for 3 days. But when you start using, you realize that it is not 3 days. It is just 2 days and 1 hour, and then it drains out. So you start suspecting that the company has overstated. The claim is not good. So in this case, it will be a one-tailed test because your suspicion is that the population mean is less than what they have stated, right? And when it comes to like charging time, the same company says if you use our new charger, then it takes only 45 minutes to fully charge the phone. But when you charge, you realize it is not 45 minutes. Sometimes it's 1 hour, sometimes it's 70 minutes. So again, you start suspecting that company is misguiding you. So this is understated. So you suspect that the charging time is more. So in this case, again, you will have one-tailed test because the mean charging time company claims that is 60 minutes, but you feel it is more than 60 minutes. So it will be a one-tailed test on the upper side. If you're not sure whether it is less than or more than, but you suspect that yes, it has changed. So when you feel that it has changed or you're not sure, like in this question, the population which was taken from $80,000, I mean the population or not. So we are not sure whether the population mean is $80,000, less than 80,000 or more than 80,000. So in this case, we do two-tailed test. So when you're certain what you're doing, when you are suspecting a less or more, then we do one-tailed test. If you're not certain, then you do two-tailed test. And sometime in the question also, it's very clear. If the question asks you test at 5% level, whether it has increased, whether it has decreased, means it is one-tailed. And when it say check at 5%, whether it has changed. Changed means either it's increased or it's decreased. So you have to do two-tailed test. Does this answer your question, Pooja?
Yes, it definitely does. And thank you so much for your efforts. It means a
You're
lot.
most welcome.
Thank you.
Any other question? Please send the recording link. Fine. Hassan always does that. Thank you, Hassan, for that. And John sir, could you figure out how to get a phase portrait in TI, Indrani? Okay, is there a way to come out of examination mode in TI without connecting to a system? Yes, you can do this by connecting your TI to another TI which is not in the examination mode. Connecting to it to a system. Thanks, Pooja. You need to connect it with software. Jealous sir, thanks. You're most welcome. Okay. Thank you so much. I'm happy you liked it. If you have any other question from any of us, please feel free to unmute yourself and ask.
Jalad?
Hi, Mary.
Yeah, remember the question that we were discussing? It was the quadratic model. When the quadratic model and linear model, when we compare, right? The part 5, it was asking like what is R squared compared to R squared, and then definitely the quadratic model is better model in this case.
Yes.
Because the R squared is greater.
Greater.
And the next part, I clearly say that no, I am overthinking, but because I have a statistic background and then I can't really stop overthinking. But I was thinking of like, coefficient of x squared is C, right? In the previous question, C.
Yeah, I remember that part. Yeah.
Yeah. Remember that you and I had different answer. Like it shows that C has minus 2.06, 10 to the negative 9, and considering the number is up, like how much do we gain from changing from linear model to the quadratic model, because quadratic model already contain that linear model inside. And
Absolutely.
and I was thinking of how significant, like, you know, adding one more parameter, and then we are losing degree of freedom, right? So that's what I was thinking. Like, I know it is overthinking for the 1 mark question.
Yeah, absolutely. It is wonderful, like another perspective. But you know, Mary, what I thought is like, if we think of like including when we talk about the quadratic, linear is also included. So another parameter comes in and it might affect, as you said, degree of freedom. So instead of going towards that functional part, I just thought of like doing it from the R square, the significance of R square. How can we use that one?
Yeah, I know. That's why I'm saying that it is overthinking, because
no, Murray, that's excellent. What you said is excellent. You know, I mean especially
like, you know, when I mark, remember that I was marking AI, HL, IA papers, moderated AI, HL, IA. And one of the things that really I hated is students have only few data points, and they are keep on increasing their polynomial from degrees, like, you know, 2, degree 3, and degree 5 and 6. And even though apparently it is nonsense, they are keep on increasing because they are using software. It is easy. They just change the degree of polynomial, and sometimes there's no meaning, and they don't really look at the coefficient and how much it is meaningful, like, you know, adding one more parameter. Yeah, that was my, you know, always looking at students IA, and I was like, can you know, just instead of just changing the degree, can you think about what are you gaining? And
Marie, I also had an observation. In question E, it says, hence compare the models, right?
Yeah.
And there's a similar kind of a tone to that question, which says, comment the next one. It says, comment on the validity of a decision. So when you're already comparing the models, maybe I think Jalaj's and your interpretation of R square it makes perfect sense there. But when you are commenting on the validity of a decision to use coefficient of determination, maybe then, you know, the student could then refer to the low value that the value of C for the quadratic model. You know.
Yeah, so I was wondering whether in the IB exam, are they going to accept any like a meaningful observation? Like,
I would think so.
No. Okay.
If there is, yeah, I would think so. I'm no authority on that, but you know, I think if it makes sense in the context in the context of the problem, I think, because it's just 1 mark and there it is an open-ended question kind of sort. If it makes sense, I think it would be accepted.
Great. And we have a participant here, Iram Beram. Iram, which school are you from? Is it from Turkey or? Iram, are you here? Never mind. Okay, any other question, any other doubt, comments? Thanks, Mary. That was great discussion and very good feedback. And yes, another thing is like, we don't know, like there is no mark scheme for this paper. So at later stage, if you have access to these mark schemes, if you feel there is anything which was not done correctly, please let me know, let us know rather, so that we can clarify our understanding.
May I answer Indrani's question?
Yeah, John, go ahead.
Yeah, Indrani, I spent a couple of days on that, but unfortunately till now I've not been able to track that. You said that you spent about a year looking into that option for face portraits. Here's the interesting thing. I ended up in certain websites. I shared this information with Hassan. Actually, he knew about it. There are certain apps, in fact, third-party companies that are producing apps that can be incorporated into TI. Now, I don't know how legal or illegal that is, but apparently they have, this is something that I just found out when I was trying to see what are the possibilities to graph the face portrait. I've not given up my quest, okay? So I don't give up so easily. But at least in this 1 week, what I could find was, other sources which are like patches, which can solve a lot more than what we've been looking for. Okay, I can send you that link to that third-party apps. Now again, Hassan or someone else from TI will be able to let us know, because one particular thing that Hassan said, that was an operating system, but one which I was talking about was just a TNS file. It's almost like a like a macro, so it could be. However, here's the thing, I'll send you the link for each such extension. There's one extension for the DE, like the differential equations. There's one extension for calculus separately from this. So there is a company that has been providing certain other, and it just boosts the performance of the TI. So give me some more time to research. Till then, I can just email you this link. You can also take a look at it. It's paid, right? It's a separate fee for everything. But let me research whether it can be used, whether it's allowed. And if it's allowed, yeah. But till then, I'll also try other approaches. But, there's no direct way to get answer the question. But I did come across certain things, and I quickly shared that with Jalaj. Did I answer you? Please, I was wondering how to do it. I will send you, okay? If, I'll get your email address from Hassan, and I'll send it to you.
Thank you guys for attending the webinar. Yeah.
Thank you all for joining today. Thank you, Jalaj. Thank you, Shraddha ma'am. Thank you, John.
Thank you.
Thank you,
Thank you
Mervi.
all.
Thank
Mervi,
you all
thank
the
you so much. I really
participants.
like the point. I'm going to write to you later.
We will be sharing the recordings and we'll share a feedback form. So I want everyone to fill the feedback form. That will be the honest feedback we can give it to the speakers. So thank you all for joining. Have a wonderful day.
Thank you. It's okay to leave, right, Hassan?
Hello. Ma'am, can you stay back for another 10 minutes just for our debriefing?